Well, moving on quickly towards the next session, and we are going to have a presentation on next generation of grid edge digitalization. Ladies and gentlemen, we have a next keynote speaker, Mr. Debasish Das, Energy Leader, Managing Director, Inergio. He has an experience setting up COE at client site operation, customer AMS practices, area in IBM with varied exposure of support activities, including day-to-day operation, recruitment, pre-sales and customer visit, training, enablement, knowledge management, people management, and the vendor management, etc., covering 5,000 plus resources, skilled at leading a good sized team in project delivery, program management, portfolio management, account management, and process and methodology implementation. So let's welcome our next keynote speaker, Mr. Debasish Das. Hello, sir. Welcome.
Hi, everyone. Am I audible?
Yes, sir. You're audible and very much clear on the screen. Over to you.
All right. Thank you. Thank you so much for giving the opportunity. And thank you, everyone, whoever is participating, whoever is listening. So what I'll do, this particular subject is a little bit technology heavy. And this is kind of little bit advanced, part of the business processes, business functions. So what I have done, a couple of slides I have. While I'll go through the slides, I would more talking. And if you have any questions, any point in time, you just send it through message. Let me see if I can clarify a couple of your doubts, at the end of the session. So with that, what I'll start with, to give you a background, what is grid edge? Okay, so grid edge, when we started our career, 22, 23 years back. So I'm basically an electrical engineer, and that point in time, grid, I was only thinking of the transmission grid. Okay, and it was very linear approach. You just actually generate the energy from thermal, from hydel, and you push into the transmission grid, and then you get into the grid, the distribution network, and then through the distribution network, it goes to the end customer. So that was the story. But if you see today, the grid has got tremendous changes in the last decade, and there is huge technology, huge additional business functions, and also there are a lot of new things are coming up, which is basically disrupting the industry as well as the grid. Okay, so if you see today, I just actually took it from, this is probably the best image what can explain the grid. So I have taken it from Siemens. And that is, they have wonderfully depicted what is the grid edge for a layman's understanding. Okay, if you see, so there are everywhere there are changes. So generation, as I told sometimes back, I mean, quite a couple of years back, it was only limited to a couple of generation, thermal, hydel, and the conventional energy sources. But if you see today, the renewable and also the, I would say the additional byproduct of renewable, or actually the downstream of the renewable energy sources, that also have got some energy kind of storage and some kind of energy supply. Okay, so if you see here, so renewable is there, energy storage is there. You also know the concentrated solar plant or wind, actually how you can convert the renewable sources to heat, and then again actually you get the electricity out of it. So that's one area where the generation points, generation sources have been changed, and right now today it is called distributed energy sources, because there are different sources of energy generation, and it's not only in the big companies or big industries those actually generate. Very small generators are there, those are actually disrupting the whole grid. So in terms of the small wind turbine, or actually the rooftop players, small rooftop players, so they're in massive and they're actually putting their hand into the grid in terms of the generation. So that is one story of generation side. If you see, as part of this complexity around the generation, so you have got now also there are some middlemen who those like just Uber. Uber does not have actually a fleet, okay, but they are the owner of the virtual owner of a large fleet. Something like that, if you see today, that is the virtual power plant coming out. Okay, so the virtual power plant is someone who is aggregating the energy from different sources, and actually they are selling out to the customer with actually a kind of very optimized price for the commercial industrial customer, and even in some cases to the retail customers, community customers. Okay, so that's where this is another set of energy sources for customer. This is a source, though it is coming from the generation sources of renewable or actually mix, but it is for customer, this is another source where actually he can go and buy. Okay, so that is all the generation side. Then you come basically the consumption. So the consumption, we are actually using the electricity for the home purpose. Right now, if you know, actually there are EVs are coming up. There are hundreds, thousands, millions of EVs are on the road. Buses are on the road which requires charging, and for that you also need the electricity energy. So it's now the electricity, I used to tell it was static, right now it's a dynamic as well. Okay, it's a moving electricity, so what you need. Okay, then the third part, what Mr. Patnaik just actually very nicely told in my previous session, in this previous session, so that is the performance, the energy savings and energy efficiency. That's a big area which is actually emerging now, with lot of new innovative startups have come up, and they have got the building energy monitoring, the building performance, the commercial industrial customers, price optimization, microgrid. There are lot of things are coming up, how to do the efficiency and how to bring up the performance into the overall consumption. Okay, so why actually I'm telling this? So if you see, all these are connected to the grid. Okay, so everywhere, whether we are generating or we are consuming, so that is all connected to grid. And having so many people, so many stakeholders, think of the complexity today. Okay, so it is just not the grid, the challenges actually at the transmission line. Of course, in the transmission line, you have got now thousands different sources of renewable penetration, which actually the transmission system was not planned for. Okay, and then the way the renewables are penetrating, the way the energy storages are coming up, so the transmission companies are also in a big challenges how to manage that. Okay, so that is one, the transmission line. And the grid, the distribution network, where actually the major challenge is seen today. Okay, so because all these consumers, the small energy suppliers, as I told, so when they actually bring up to the grid, distribution grid, so the distribution grid is not as robust as transmission. So there, you might have seen actually in a couple of states, even in India, it has been actually experienced. The transformers are getting burnt, the distribution network is getting failed. That is because of no control what actually energy is getting pushed into the distribution line. It's a very small, fragile network, right? So you need to have actually the control, how to have the permissible limit of energy getting penetrated to the distribution network. And the scenario would be really getting complicated when the EVs would be many in numbers, and because that is very transient energy requirement and very dynamic energy requirement what actually the EVs would be needing. So in a nutshell, we know actually the grid is getting complex, both transmission and distribution. We need to have proper monitoring and control, so that actually everyone gets within the permissible limit and the grid thrives. Okay, so that's what actually the grid is. Coming to my next screen, so this is bit actually I'm sure you all know, but this is the kind of trend. Okay, so what are the things coming up which are actually impacting the grid? So the smart appliances at your home, consumers, peer-to-peer trading, though in India a couple of pilots have been done, but in countries like Australia, so this is very well possible today, how energy can be sold peer-to-peer from your neighbor. You need to have a lot of regulatory environment. You need to have that flexibility, because there are new business opportunities are coming up. So battery swapping is an business opportunities. Hydrogen is a business opportunities. So like that, there are a lot of new business, and also the the urban microgrid, rural microgrid, the BPP. All those are new business opportunities which we have not thought 10 years back. Okay, so the regulatory needs to be kind of be supportive, and they need to actually open up the things. Have at the end, retail customers or commercial industrial customers get saved and get optimized price, and at the same time utility also manage their load and the revenue. Okay, battery technology everywhere it is coming up, small to utility scale. Electric vehicle, as I told, a lot of electric vehicle would be on the road, and which would actually, and then electric vehicle, when I talk, this is not just only the consumer perspective, this is a prosumer. So what is prosumer? So the producer and consumer. So if you have an electric vehicle, so you can actually take the energy from grid to charge your vehicle when you need. And when, suppose if you are not working today, and your car is actually fully charged, you can connect to the grid and you can sell the energy from your car to the grid. Okay, that is very well possible. That the technology called vehicle to grid. Okay, so in advanced countries there is already the stations where actually people can have the bi-directional communication. They can actually charge or they can sell also from the car to the grid. Okay, and think of from the time of use. So utility, actually the pricing is dynamic. Okay, if the pricing is dynamic, so you can charge actually your car at a very low price time, and you can sell the electricity from your car to the grid at a very big price. Okay, so that in that way the car can be your one revenue source. Okay, home energy managers, as I told, home automation and those kind of stuff. Then the this is actually the rooftops, the consumer owned generation, affordable for average household. And then the microgrid. Okay, so these are actually the infrastructure wherever you do not have the rural area where the infrastructure is insufficient or the grids are weak, so you can have actually the rural microgrids there for the self-sustenance. Okay, so these are a couple of trends what is coming up, and these trends are all actually connecting to the grid and having an impact. So if you see, I just actually brought a very, draw a diagram which can explain why we need the grid technologies, okay, or the grid edge technologies. So grid edge technologies is, there are a lot of things, but if you say in a very layman term, you need to monitor and you need to control. If you can monitor and then if you can control in nice way, then actually your grid can be managed. So what I'm just giving you a point of view here. So from the generation till your consumer side, how it happens. Okay, so you have got multiple generators. So those are pushing the data to the transmission network. And the transmission network, this is actually, again, as I told, I mean, it has been, you cannot actually create a tower in a day. Okay, so the transmission network is limited, and it all requires, how much load it can take. And if you do not have the proper control and the monitoring capabilities, so they are actually going to be the massive challenge, like the one what we have, the frequency imbalance, the experience what we have in the past. Okay, so OT is basically the operational technology, and operational technology is nothing but how you can connect to the different source of energy or flow of energy, how you can monitor that, and how you can control. So that's where I'm telling, it was merely limited to SCADA earlier days. Even today also, if you see, the SCADA plays a very vital role, but SCADA is very, very limited to the technology or to the the regime what actually we are approaching. Okay, so you need to have a very robust, very intelligent, simulation based, analytics AI based solution where actually you can monitor, and at the same time you can fire the command to control the network which is going upshoot. Okay, so that's why what I told, this is the transmission network, and from the transmission network you are having entering into the distribution network, and this distribution network is getting more complex like a cobweb, because you have got the retail customers, you have got the prosumers as well, You have got the commercial industrial customers. They always think actually how to get the energy saving, whether they should have a solar panel or they should have a utility scale storage, or they can have hydrogen, small hydrogen plant. When I'm talking of hydrogen, I'm talking of next 10 years, not today. Okay, so all these commercial industrial customers, retail customers, they have got the demand. At the same time, they are also they can actually generate. So that's why you need to have the both side control. So what actually I was working with a company. We are actually in Inergio. We are working with a UK based company where actually they have got the device. So uh, which actually gets connected to individual generators, okay, rooftops, and it's a bidirectional flow, and the utility operators in the particular region, they have got the access to the device, and they can just actually see the demand, and within minutes, if there is actually going beyond the threshold of the distribution energy, whatever actually supposed to flow, so they can fire the command and they can curtail hundreds and thousands of rooftop players in a minute of time. Okay, so that's how actually it looks like the thing should be down the line 10 years. You need to have the control where actually the massive control needs to be there in the distribution network operator hand, where actually he can just plug and play, and then he can just actually simulate and control on the real time the energy flow to the network. Okay, so this is more actually we talk and more lot about edge computing, but these are basically the solution of edge computing, how the device and the edge computing is going to play a very big role in the overall grid. Okay, it's a very simplistic diagram just to give you a pointer, but it is extremely complex when we talk into the network modeling and network monitoring and network control. Okay. The next one, technology takes a center stage. Yes. So we were limited, 10 years back, just limited to a couple of devices, which actually was bringing up the fault defect from the network and actually pushing that, and we computed files we used to analyze and we understand what is going on the grid. And SCADA was the limited thing where actually we had the access and looking into on the real-time data. But today, if you see, the data is changing, the data is massive now, and you need to have the real-time monitoring. So that require a very, very high performance data platform. You need to have multiple stakeholders are there in my first screen, what you have seen. So for that, you need to have the slicing, dicing of the data to feed to different type of customers, consumers. So you need to have the security as well. And most importantly here, the geospatial analytics and data analytics is going to play a very, very vital role while you are monitoring and simulating. So I can think of actually a particular solution when I, as an operator, when I open, if I have a limited area of coverage, say 50 kilometers, and I should actually see within that 50 kilometers coverage, what are my energy points and what is the maximum demand coming up. Is any particular sub area where actually the transformer is likely to fail, the load is continuously increasing for the last couple of hours, and then the pattern is for the last 20 days, it is 1%, 2% getting increased. So those kind of the view, if I see that, what is my forecast and demand, what is my pattern happening in the particular area where it is increasing, then I can immediately take a call. Okay, so and it should be basically how you can actually bring up the network and the customer on the same platform. So if you have a challenge, you can actually push the customer to the notification that, guys, so 10 o'clock to 3 o'clock, there is a massive demand in your network in your near vicinity. So if anyone actually switching off or cutting down the load during that time frame, they can get a 2% rebate. Okay, so that's the kind of incentive based simulation and monitoring, and again actually the actions. We should have that kind of utopia where actually the things can be done. Otherwise, it would be extremely difficult. There will be a lot of disturbance into the network, and the distribution network is likely to fail if you don't have, the very, very real-time based analytics and the decision-making support tool. Okay. So this is required, all these things, and then what it can enhance. Of course, the forecasting plays a very vital role into the transmission business. But even today in the distribution network with the EV, like suppose if a particular area is the urban area, and the EV charging points and EV the cars are actually increasing, the vehicles are increasing. If we get those data, how many vehicles are getting added into the particular region through third-party sources, so you can actually forecast how your distribution network should be there in the next 5 years. Okay, at least in a 5-year horizon you need to actually plan, because the way things are moving, it is exponential. If you plan it, actually the utility as an utility, if you just plan for 1 year or 6 months, it's not because in India everything actually happen overnight, and the incremental are actually not linear. Okay. Scenario planning, as I told, in a particular network, you need to see actually what is the feeder point, which feeder is actually likely to take more load, how actually you can bring up if you have the limited infrastructure, how you can tell customers to go for some kind of storage or some kind of distributed energy sources to manage actually the demand from grid, how you can schedule. So this is more important in terms of the controlling. If you have a peak time and you see the continuous challenge actually during peak time, you need to provide the scheduler, and the scheduler should automate send the command to curtail down if you have got major energy pushed into the networks or the demand. Okay, so that's kind of the scheduler. It also holds good for the transmission business, how you actually schedule the forecasting data and then send it to the trading for the trading. And this is the trading is more actually not limited to conventional trading. It is also coming up with the small generators, how they can sell within their neighbor, within their community, and then through the BPP, how they can actually sell to the commercial industrial customers during the peak time. So that's what actually the flexibility. So it needs a platform where the technologies would be there, and where actually you would have different use cases depending upon the business processes. Opportunity here I see for everyone, though the system is complex, though the business is getting extremely challenging. So for the utility, they can actually reduce the power purchase price with renewable mix, both actually small scale generators and large utility scale generators. They can have actually a very nice way to manage the small energy generators, and in that way they can manage the maximum demand in an intuitive way. For the commercial industrial customers, they can optimize price with distributed energy mix and the controller, at what time they need to get fed from which source of energy, so that it's an intelligent way to control your energy pricing, okay, or energy consumption. Then you have got the monitoring control, how to save on energy. And this is more actually for the consumer side. It has the ability to be a prosumer. Everyone can actually put a rooftop to earn money from by selling the energy to grid. And you can also own actually the virtual power plant as an organization or as a company. Okay. A couple of areas every utility must focus, depending upon the size of the. So one area is grid integration. The other area is smart grid automation. The third is the new business segment, and the fourth is the customer. So there are a couple of things what I have put it. So this is more DER, the scale storage, wherever the maximum demand challenge is there, how that can be offset through the utility scale storage. Not necessarily it should be near to the the generation point. It can also small storage you can have, not utility scale storage, and you can aggregate the small scale generators, and you can manage locally from the storage at the peak time. Okay. Optimized grid planning, this is more actually the transmission line and distribution network planning. Smart grid fault and status, what we used to get from sensors, but there are very advanced sensors are coming up nowadays. Obviously smart meter implementation that gives the real-time energy flow at every junction. Predictive asset maintenance, and then the vegetation management. Okay. New business segment, you have got electric vehicle, you have got customer services, which is on demand. They need to see what is the consumption pattern. They need to also have the technologies, how to save. So that demand would be coming up. Storage business as is. Hydrogen plant is going to be come up, and hydrogen to grid integration is a new phenomenon coming up. Who knows, probably down the line, a decade or so, this might actually play a very vital role. Okay. Rural microgrid for micro entrepreneur generation scheme. So you can create actually entrepreneurs at the rural area, and they can help actually the utility grid. Customer, a platform to become prosumer, energy saving recommendation, and of course there is the framework policy to make it linear, how easily actually they can sell the energy, and how easily they can actually wear a hat of prosumer. Okay. I know, so this is kind of a bit complex. But I tried actually just to explain the basics. But if you have any question, I'm happy to take it.
Yes, sir. There are a few questions.
Yeah.
And I would be reading out those questions for you. So
Yeah.
the first question is, what is the outlook for storage with regard to its role in microgrids and as an enabler for renewables?
Yeah. So microgrid, what I say, microgrids are two types. So one is rural microgrid, the other is urban microgrid. So, and then on rural microgrid, you have got two variant. One is on grid, another is off grid. So why actually we need storage in rural microgrid or urban microgrid? Rural microgrid is very simple. During daytime, you can actually feed from solar, and during the evening, night time, you don't have solar energy. You can store the energy in cell and battery, and actually you can feed from battery to consumers. Okay. Same thing happens even on the commercial urban microgrids. So having the batteries, the storage, you can keep the storage, and you can actually optimize based on the time TOU. So there are 5 categories of timing where actually the energy prices varies. So you need to see which timing would be. So if you have got actually mixed sources, solar, wind, scale, storage. So you need to actually see, and that's where the controller and the analytics optimization comes in play. But storage is nothing but gives another source of energy where your solar might not be there, or actually you need to have a second hand with other sources.
So there's one more question. How do you define grid analytics versus utility analytics?
Okay, so grid analytics, utility analytics, from the naming conventions, if you see utility, so it is more actually customer network related. Okay. No, I would say the customer related. So customer, if you see utility analytics, it is more actually looking into the collection, the billing, the customer satisfaction. So those kind of the things. And that grid is more where actually you have got the network simulation, network monitoring, network operation. So, but it is not necessarily. So you in utility analytics, we take care actually the grid monitoring, and even actually on the grid monitoring today, as I told, while you have got a vehicle to grid, and so that is pushing the vehicle to grid, the person driver is pushing the energy directly to the grid. Okay, so there is a very thin line difference today, though it was, as I told, 10 years back, it was completely different areas. Grid analytics was more limited to the transmission lines, and utility was taking care of the everything, distribution network, distribution customers, and the collection billing. Okay, but more or less utility, it would be more customer centric, and grid, it would be more network centric, I would say, and asset network and asset centric.
All right, sir. So there's another question. What exactly is the difference between ADMS and DERMS?
Okay, ADMS is more, with my limited background, ADMS is more, you have got how quickly you are basically change the, the feeders from the grid and how, suppose if you have got actually demand in one particular area, the feeder is overloaded and one is underloaded, how quickly you can change and you can manage the balance on the grid, okay, the feeder standpoint, okay. And as a matter of fact, you need to monitor everything, substation, feeder, coupling points, all these things. So that is more actually demand management system, advanced demand management system. So how you can actually manage the grid and feeders. So the DRMS is more distributed energy resource management. That is more how you bring up your different sources of energy, mix and match for your power demand management or power purchase. Whoever is selling that actually would demand, and whoever is taking that is the purchasing. So DERMS is more distributed energy resources. That how you actually bring up the energy resources from different parts of the source. But ADMS is more how you manage actually the demand in the network.
So one last question. The question is IoT regulations impacting smart grids. So what's the situation in India?
Sorry, I didn't get that. Can you please repeat it?
IoT regulations are impacting smart grids. So what's the situation in India right now?
I would say I have very limited knowledge what is going on in India from the IoT practice standpoint. Though I know the things should be very, very different with penetration of 5G. Of course, in India, there is the little bit actually challenge in the customer side, the data privacy, the network availability. So those are there. It has got actually one challenges. From the compliance standpoint, from the practice standpoint, Government of India new policy, I am not very much aware of. I should sorry about that. But what I see today, even in IoT, wherever actually we put in India, we have the challenges in getting the time, getting the data in real time with the required frequency, having actually the security and privacy all across the IoT network, starting from the generation point to the customer point. So that's a challenge. There is no standard framework. And the third thing is the most important, wherever the IoT is there is a coupling interface. Okay, so there is no standardizations how actually the IoT data would be getting pushed with a standard, so that whoever puts the device, they should understand what is my interface requirement, what is my security requirement, so that actually I plan that. So it's today in India, it's more actually everybody has, every utility, every state has got their own practice, the way of working. So there is no standardization, national standardization as such.
Well, sir, thank you. I think you have answered all 5 questions. Great, sir. For whatever remaining questions, we are going to send you on your email, sir.
Sure. Thank you. Thank you, everyone.
Thank you.
Bye.